sketching graphs. Sometimes you'll be asked to draw a graph of a line or a curve accurately, and sometimes you'll be asked to sketch a graph. So what's the difference? Well, when you need to draw a graph accurately, you will be asked to draw it on graph paper. You're usually asked to find and plot pairs of coordinates and join them together correctly with a straight line or a curve. The instruction you'll be given will be plot and draw, or just draw, and you're often given the set of x values you should use. If you're not given a set of x values, then you should make full use of the graph paper you are given. You may also need to draw a graph accurately because you have to use it in some way. For example, you may have to find an appropriate solution for an equation. When the instruction in the question is sketch a graph, then you're usually only given the x-axis and y-axis. You don't plot points and you're not expected to measure and mark an accurate scale. Occasionally a scale is marked on either the x-axis or y-axis or both, but this is not common. For a curve, the instruction sketch means make a simple freehand drawing showing the key features. When you need to make a sketch, the instruction sketch will be used in the question, and you're not always given the set of x values that you should use. In this case, you should draw the full shape of the graph so that all the key features can be seen, and usually mark the coordinates of any points where the graph meets or crosses the x-axis and the y-axis. You may also be asked to mark the position of other key points, such as turning points, if there are any. Remember that a straight line graph should always be drawn with a ruler, whether it's a sketch or an accurate drawing. And, like a curve, your drawing should show the key features. Let's begin by looking at how to draw straight line graphs. When the equation of the graph follows the pattern y equals mx plus c, for example, y equals 2x plus 1, the graph will be a straight line. In this Cambridge examination question, the equation of the line is y equals 4 minus x. If you rewrite this as y equals minus x plus 4, you can see it fits the pattern for the equation of a straight line. First, you have to find the coordinates of 2 points. These points are the points of intersection with each of the coordinate axes. How can you find where the line crosses the x-axis and the y-axis? You may wish to pause the video while you think about this. Okay, on the x-axis, the value of y is always 0. This means you can find the answer to part 1 by putting y equals 0 in the equation of the line. You can then solve the equation for the value of x. So let's consider what happens on the y-axis. On the y-axis, the value of x is always 0. This means you can find the answer to part 2 by putting x equals 0 in the equation of the line. You can then solve the equation for the value of y. You may also know that the value of c in the equation y equals mx plus c is actually the y-coordinate of this point. These 2 points are very important, so a good tip is to make sure that you are confident with finding 2 pairs of coordinates, as they will help you a lot. On this part of the question, you need to draw the line. You've been given the graph paper and you have 2 points. You don't have a set of values for x, but if you make sure that you use the graph paper fully, you will have an acceptable answer. You should plot each point and then draw, as accurately as you can with a ruler, the straight line that passes through the 2 points. A good tip is to check a third point to try to make sure you've not made an error. Reading from the graph, you can see that the point 1 and 3 is on the line you've drawn. You can check this in the equation of the line. The equation is correct for this point, and so your answer seems to be correct. Notice in this question, you've only found and plotted 2 points. More often, when you're asked to draw a graph, you are asked to complete a table of values and plot several points. You'll see some examples of this later. Also, the x term in the equation of this line is negative, and this results in a line which slopes down. Let's now look at a Cambridge examination question that requires a sketch of a graph. Notice that in this question, you're not told the graph will be a line. However, if you check the equation of the function we've been given, you can see that it fits the pattern for y equals mx plus c. The graph you will sketch will need to be a ruled line. Just like the previous question, it's helpful to know where the line cuts the x-axis and the y-axis. There are no marks for doing this in the question, but it is a useful task to complete. When x is 0, the value of y is -3. When y is 0, the value of x is 3. There is no scale marked on the x and y axis, so you don't have to measure and mark a scale, and an approximate position is good enough. You mark 3 on the x-axis and -3 on the y-axis, and then draw, as accurately as you can with a ruler, the straight line through these points. You make the line long enough to make full use of the diagram we have been given. Notice that the x term in the equation of this line is positive. This results in a line which slopes up. Okay, let's try another example. Your friend Lee has attempted to answer this Cambridge examination question. Let's check Lee's working and answer. When you substitute -1 for x in the equation of the function, you get 9, not 7 like Lee. Lee has calculated that -1 squared is -1. This is a common error when squaring negative numbers using a calculator. You can avoid this error by always using brackets when squaring negative numbers. When we substitute 2 for x, we do get -3, and so Lee's second point is correct. When we substitute 3 for x, we also get -3, and so Lee's third point is correct as well. If you're allowed to use a calculator to find the values, a good tip is to check to see if your calculator is in table mode. You can use this mode to find and check coordinates. Now that you've corrected Lee's coordinates, let's look at his graph. Is it correct? You may wish to pause while you think about this. The instruction in the question is to draw, and we have graph paper, so we should plot points and join them together, which Lee has done. We know Lee's first point is not correct, however he has plotted all his points correctly using the values in his original table. This means that he's tried to draw the graph from the x equals -1 to x equals 5, which is correct. You can see that Lee has joined his plotted points with straight lines. Is this correct? No, the function is a quadratic function. It has the pattern y equals ax squared plus bx plus c. If you could plot all the points in between those that have already been plotted, you would have a smooth curve, so the points should not be joined together with straight lines. You should also be careful to ensure that the curve does not have a flat bottom. The lowest point on the graph is a single point, not a line, so the graph Lee should have drawn should be more like this one. If you look at pairs of points with matching y-coordinates, you can see that the graph has a line of symmetry which passes through the lowest point. Notice that the x squared term in the equation is positive. This means that the curve opens upward. Sometimes we say it's a happy curve or a smile shape. When the function whose graph we're trying to draw has terms that are powers of x, such as x squared or x cubed for example, the graph we draw should be a smooth curve. Now let's look at another Cambridge examination question that requires a sketch of a graph. Notice that in this question, you're not told that the graph will be a curve. However, if you multiply out and simplify the right-hand side of the equation you've been given, you can see that it fits the pattern for y equals ax squared plus bx plus c. So this is a quadratic function just like the previous question. So the graph you sketch will need to be a smooth curve. As the x squared term is positive, the curve will open upward. So it's a happy curve or a smile shape. It will have a lowest point and will be symmetrical. The sketch should show the symmetry of the curve and not be pointed or flat at the bottom. It's helpful if you know where the curve cuts the x-axis and the y-axis. There are no marks for doing this in the question, but it's still a useful task to complete. When x is 0, the value of y is 1. And when y is 0, the value of x is also 1. Notice that this curve doesn't cut the x-axis in two places, as when y equals 0, there is only one value of x. What does this mean? Well, the graph must touch the x-axis. In other words, the x-axis is a tangent to this curve. You may wish to pause the video while you try and sketch this graph. There is no scale marked on the x-axis and the y-axis. You do not have to measure and mark a scale. An approximate position is good enough. So you mark one on the x-axis and one on the y-axis and then draw a smooth curve through these points. If you find it difficult to sketch the curve through these points, a good tip is to sketch the curve in the correct position first and then mark the points on afterwards. In this question, you are again asked to complete a table of values and then draw a graph for a particular set of x values. What should this graph look like? Is it a straight line, the graph of a quadratic function, or is it something else? If you rearrange the right-hand side of this equation, you can see that it fits the pattern for y equals ax squared plus bx plus c, so it will be the graph of a quadratic function. Now complete the table and draw the graph. You may wish to pause while you do this. You should have the y-coordinates -5, -2 and -5. When you plot them and draw a smooth curve through them, you should have a diagram like this. Notice that the curve is symmetrical, but this time it does not have a lowest point, it has a highest point. The line of symmetry still passes through this point. The graph does not open upward, this time it opens downward. Sometimes we say this is a sad curve or a frown shape. Why is this? In this equation, the x squared term is negative. When you have a negative x squared term in your quadratic function, the graph will always open downward. Notice that this curve does not cut the x-axis at all. We have now seen graphs of quadratic functions that cut the x-axis twice, touch the x-axis once, and that do not cut the x-axis at all. This is possible for the curves that open upwards or downwards. In this question, you are asked again to sketch a graph. What should this graph look like? Does it fit the pattern for a quadratic function? Yes, we can see that it fits the pattern for y equals ax squared plus bx plus c. The graph you sketch will need to be a smooth curve. You may wish to pause the video while you try and sketch this graph. As the x squared term is negative, the curve will open downward, so it will be a sad curve or a frown shape. It will have a highest point and will be symmetrical. The sketch should show the symmetry of the curve and not be pointed or flat at the top. Where does the curve cut the x and y axis? When x is 0, the value of y is 3. When y is 0, the values of x are 3 or -1. So when y is 0, there are two x values, so the curve cuts the y-axis in two places. As usual, there is no scale marked on the x-axis and the y-axis, and an approximate position is good enough when sketching the graph. You mark -1 and 3 on the x-axis and 3 on the y-axis, and then draw a smooth curve through these points. Again, if you find it difficult to sketch a curve through the points, sketch the curve in the correct position and then mark the points on afterwards. Notice that the highest point is to the right of the y-axis. The symmetry of the curve means the x-coordinate of this point is the mid-value of -1 and 3, which is 1. You don't need to mark this unless you're asked to, but it is useful information when making a sketch. In its simplest form, a reciprocal function is a fraction with a number for its numerator and an x for its denominator. There are more complex reciprocal functions, but these are not studied at this level. Let's have a look at an example. Jay has attempted to answer this Cambridge examination question about drawing the graph of the reciprocal function y equals 8 over x. Let's check Jay's working and answer. The y-coordinates Jay has found seem to be correct, and Jay has also plotted all 10 points correctly. However, before you look at Jay's graph, you need to understand simple reciprocal functions. Let's look at the table. Notice there's a grey section between -1 and 1. Why is this? It's not possible for x to have the value 0, as 8 divided by 0 has no mathematical meaning. This means that there should be a break in the graph, and it should be in two sections and not one continuous graph. Clearly, J's graph is not correct. You can see that there are two sets of values for x which we need to draw the graph. This is another clue that you need to draw two sections, not one. You must only draw the graph from -5 to -1 and from 1 to 5. If you draw parts of the graph for the other values of x, even though it might be possible to do that, you will not earn full marks. J should have joined the first 5 points she plotted with a smooth curve to form one section of the graph. Then the other 5 points should have been joined with a smooth curve to form the second section of the graph. Her graph should have looked like this. Notice that there should be nothing drawn between x equals -1 and x equals 1, which is correct for this question. If your course requires it, you may need to sketch the graph of a simple reciprocal function as well. Y equals 1 over x is a fraction with a number for its numerator and x as its denominator. You now know that for this type of function, you must draw two sections, as x cannot be 0. In this question, you are not given two particular sets of x values to use, so there are no restrictions on the sections that you draw. You need to look at what happens to the curve as x is very large or very small, and you need to do this for the values of x that are greater and less than 0. First, if you rearrange the equation of the curve, you can see that x is equal to 1 over y. This means that as well as x not being 0, y cannot be 0 either. So the graph cannot cut the y-axis, and it cannot cut the x-axis either. When x is very large, what happens to y? Let's say x is 1000. Then y would be 1 over 1000, or 0.001. As x gets larger and larger, y gets smaller and smaller, but it never reaches 0. The graph gets closer and closer to the x-axis, but it will never reach it as y cannot be 0. The x-axis is called an asymptote of this section of the graph. When x is positive and very close to 0, what happens to y? Let's say x is 0.0001, then y would be 10,000. As positive values of x get closer and closer to 0, y gets larger and larger. The graph gets closer and closer to the y-axis, but it will never reach it as x cannot be 0. The y-axis is also an asymptote of this section of the graph. An asymptote often causes a break in the graph, so there will be more than one section. When x is negative, what happens to y? Let's say x is -1000, then y would be 1 over -1000, or minus 0.001. As x gets larger and larger in the negative direction, y gets closer and closer to 0, but it never actually reaches 0. The graph gets closer and closer to the x-axis, but it will never reach as y cannot be 0. The x-axis is an asymptote of this section of the graph too. Let's now say that x is -0.0001, then y will be -10,000. So as negative values of x get closer and closer to 0, y gets larger and larger in the negative direction. The graph gets closer and closer to the y-axis, but it will never reach it as x cannot be 0. The y-axis is also an asymptote of this section of the graph. Notice that for this graph, when the x-coordinates are positive, the y-coordinates are positive, and when the x-coordinates are negative, the y-coordinates are also negative. You now need to sketch a graph of this function. What type of function is this? If we rewrite this, we can see that it is a fraction with a number for its numerator and x for its denominator. So this is a reciprocal function. In this case, when the x-coordinates are positive, will the y-coordinates be positive or negative? And when the x-coordinates are negative, will the y-coordinates be positive or negative? Think about this and use the logic from the previous example to help you sketch this graph. You may wish to pause the video while you do this. When the x-coordinates are positive, the y-coordinates will be negative. And when the x-coordinates are negative, the y-coordinates will be positive. This means that the sections of this graph will be in the top left and bottom right corners of the diagram. The x-axis and y-axis will be asymptotes as they were before. This is what you should have drawn. Notice that when sketching, the only important thing about the number on top of the reciprocal function is whether it is positive or negative. Apart from that, the size of the number does not really change the shape of our graph, as you do not mark any values on the diagram. The shape is basically the same if we have -2 over x or -10 over x, for example. So, when asked to draw the graph of a function, you need to do so accurately. This means you will need to find and plot points and then join them together. When asked to sketch a graph of a function, the only points you're likely to need are any points where the graph cuts or touches the x-axis or y-axis. For a curve, making a sketch means making a simple freehand drawing showing the key features. For a straight line, always use a ruler whether you're sketching or drawing. The pattern y equals mx plus c is the equation of a straight line. The pattern y equals ax squared plus bx plus c is the equation of a quadratic function. And the pattern y equals a over x is the equation of a reciprocal function. Remember, read each question carefully before you decide what you need to do, and use your calculator carefully when finding values. Good luck!